Well, hi, good morning. Thanks so much for joining me in my shop. So I'm going to do a little work on this radio here. This is the General Electric C545 is what it's called. I've already got it out of its rather interesting looking simple box here, or cabinet. There's the radio itself. Now, the thing about this radio is someone else has worked on it already. I look underneath. Someone's put in these capacitors, done a nice job, quite a nice job on that. Put in this yellow one. They've left behind this guy, molded one. These two here, they've left them in. So operating condition of this radio, I'm not so sure about it. It's a very, very simple radio. It's not a lot of parts in it at all. It's a 5-tube radio. Almost certainly has the chassis, hot chassis problem with it. But let's give it a go. See what happens here. Start off with. Okay. It's good. On-off switch must be working. I'm going to switch it on. Now, see, I'm holding on to this now. This is out of the cabinet. There's no transformer. It has 5 tubes. One of them is a 35 something, the other is a 50 something. And the rest are 12s. I mean, it's quite clear that this is potentially a hot chassis radio, high potential. The chassis is energized through a capacitor. That's the normal way. And so, can you get a shock? I think you can get a minor shock from it, but you can certainly get a shock. And even a minor shock can cause you to drop things or do other stuff. So, lots of concern with a radio like this. No transformer, 5 tubes. AM only. These are all indications that it's a 5-tuber. So when I grab this knob, I am now touching the chassis. So if I'm touching something else, you can see I'm not. It would be a little bit dangerous. In my shop, I keep myself safe with an isolation transformer. Not too worried. Wow, do you see how much that flashed? That just flashed like crazy. So that's the inrush current rushing into the tube heaters. I don't know how they came across on the camera, but it was like a flash bulb going off in here. That doesn't bode well for this light in the long run. But, these tubes, if any one of them lights up, they all light up because they are in series. The heaters are in series. So you can see they're lighting up. Let's see what we got here. I'm on restricted power still. Nothing yet. They take a long time to warm up on restricted power. The voltage being supplied right now, well, it's 105 volts. That's just about normal. Come on, little radio. Now we're off to a good start. Okay, we'll do a little bit of tube wiggling here. I'm going to turn this up a bit. Output tube. Okay, that tells you that there's something getting to the output tube, or the output tube is operating. It doesn't mean anything's getting there. Next one behind is the 12AT6. And this next one here. Kind of a crude way of testing a radio. So I can hear the wiggling all the way through. I just turn it up. That's one of the easiest ways to fix a radio, is turn the volume up higher and higher. There's a station there. We're still on restricted voltage, 105. Let's get it full. Probably not going to make much difference. So it's receiving. Judging from the work that was done by the last person, the radio is probably tuned up properly. Let's just fiddle with the IF a little bit here and see. Pretty good there. And I don't know that it's tuned to the correct frequency. There's something something is a bit of an intermittent thing there. Yeah, so this has been tuned up, but again, I don't know if it was done with instruments. So the capacitor is a two-part capacitor here, of course. One is okay. So dirty volume control here. Oh, is that really the volume control doing that? So one of these is going to be adjusting the oscillator and the other one adjusting the antenna. Oh my gosh. It's exactly the same situation here. Okay. I'm not going to be able to align a radio. That's where I'm heading with the volume like this. Power off. Stop. We're going to try to clean this volume control here. Let me turn the power off over here. My magic elixir here. Yeah, if you don't like WD-40, don't watch what's going to happen here. I want to spray it inside the volume control. Pretty short power cord on this radio. Let's try it again here. Right in past the terminals here. That's a pile. That's a pile I put in there. Okay, let's take a little bit of it out. WD-40 always looks like a lot when you first spray it because it foams up. Okay, let's see how that did. Why don't we fix this right now? Pretty tight, just like that. Yeah. Good. I can't believe it. I did that. Good. Okay. Enough of that craziness. There's a chance the top of this screw is now shorted to this chassis. I'm not going to worry about it right now. Okay, back to what we were doing. What were we doing? We're getting ready to align this guy. I've done a little sensitivity. It seems pretty good. I have the schematic for it. Okay, before we go any further, let's just take a quick look at the schematic here. What I'm looking for is how is the chassis connected to the radio circuitry inside. And so as I look around the schematic, I'm looking for anything that looks like it's tied to the chassis, like that, and like that. So those are the things that are connected to the chassis. From this would be the negative bus wire inside, or negative circuit inside the radio. So 0.2, that's a fairly large one. 330k resistor is fairly typical. The idea is this will restrict enough electricity that if you should come into contact with this negative bus, maybe through that screw on the back of the radio, while you're hanging on to your faucet with your other hand, that the amount of electricity that will flow in your body is not enough to kill you. Big resistor like that, you probably feel the tingle. So what can happen, of course, it's a long shot that this could short, or some other thing could have occurred in the radio, including other people working on it and not understanding this kind of stuff and making a mistake. Now, why did they even bother doing this? Like, why not just leave the chassis just kind of floating there? Because it becomes an antenna. It receives signals, including things coming from the radio circuitry itself, and then re-radiates them. And so you have a big noisy piece of metal laid up against the radio. That's no good. So you want to drain all that noise out of the chassis, out of the metal frame, and you do it through these two items. This is enough to solve that problem without introducing a shock hazard. This is what this technique's all about. So it's really important when you get one of these 5-tube radios, everything in series here, all the heaters in series, that you identify this and then find these in the radio and check them and see. Maybe even, if you're really concerned, get your voltmeter out, for crying out loud. Put it on the chassis, put it on something that's grounded, fool around a bit. Check this thing out. I'm not so concerned in here because I have an isolation transformer, but as soon as I begin connecting 3-prong pieces of test equipment to this radio, it's no longer isolated. So I'm avoiding that right now. At first, I've got my signal generator here. Okay, putting out a signal at 1 megahertz, kind of the middle of the band here, more or less. Its signal is being fed into this. This thing is just a coil. It's just a coil of wire up here. That's all it is. And what I'm hoping to do is inject enough signal from here into the radio that I can align the IF. It's not quite the way you're supposed to do it, but I'm avoiding connecting this radio to my equipment. That's what I'm trying to do. A little experiment. Let's give it a go and see what happens here. I believe, of course, one of the things that sticks out on these radios is the antenna potentially. A lot of them have a connection on the back to put a wire antenna. So this one comes with a loop antenna. You can kind of see it right there. But there is a connection on the back to hook up another antenna. So how can you have this sticking out and really an antenna is a piece of wire you're going to handle almost for sure. You're going to walk around a little bit with it. I mean, you're really going to run a reasonable risk of touching the antenna and then grounding yourself somehow. So what they've done is they've stuck a capacitor in there. 0.005. My understanding of this is that this has nothing to do with making the antenna work. This allows the antenna signals to come through. But at the same time, if you touch the antenna wire, the only shock you'll get is the small current that will trickle through this capacitor. So that's what's going on with these radios. They're all very similar in terms of how they handle these hazards. As the radios got newer over time, they took more and more steps as people kept getting shocks from them. From things like the screw sticking out the back, the screws holding the feet in underneath, or just holding the chassis into the cabinet. Look at here. So this is, look at these. I've never really noticed this before. But so this piece of material looks like it's riveted onto the front panel, and then the screws that come up from underneath that hold the chassis go into this non-conductive material. So the screws underneath, which you can pick the radio up like this, contact those screws, and then with your bare sock feet step upon the concrete basement floor, and if it doesn't kill you at that point, you will almost certainly throw this radio, and that'll be the end of the radio and whatever it hits. And if it hits your wife, you're really in big trouble. So we don't want that stuff to happen. So part of it is how they engineer the radio, but the main part, if you're fiddling around with these things, is your own knowledge. So hot chassis. Go to a website called Just Radios and find a page on hot chassis and read it before you play around with these things and get killed. We don't want that to happen. Okay, enough talk. I was going to turn this on. I never turned it on. Power on. Big light flash again. Even this light's flashing too. Kind of shows you how much power is rushing into the radio at the initial on moment. Some people say these lights are designed to restrict that inrush. I don't think that's the case. That's not what's going on. This is supplying 12 volts to three. All the tubes are in series. Some of them are dropping 12 volts. There's a 35 and a 50. Nothing is dropping 6 volts. There's no 6-volt place to hook up a 6-volt light. There's really no place to hook up a light unless you want to put the light in series. That's not the way this is done. There's a trick played in the filament of the rectifier tube that produces a voltage. Basically, they use the rectifier tube heater to voltage divide. Maybe it's not the rectifier. Yeah, I think it is. The voltage divide, I don't know. Yeah, right. Stop talking, Jim. Hold it right there. I think I'm telling the story wrong. Anyway, you should read up on these lights. Come on, little radio. There he is. I was just about to adjust it. I was getting around to adjusting that when I got all involved in there. So I want to determine for sure which one is the oscillator, which one is the... It's easier here. So C2B and C4 trimmer. C4 trimmer, this is the oscillator section. I can see how the feedback's arranged here. So C4 trimmer. Less plates is the trimmer for the oscillator, but I want to fiddle with the front end tuning. Just see if it peaks up a lot. Oops. No. You gotta be tricky with these radios because they have an AVC. So if you detune them and the signal going through the radio reaching the detector is reduced, then the volume of the radio comes up. Okay? Trying to keep the overall volume the same. So if you're doing that, what you really want to listen to is the noise. There's a noise going up and down. This might be all there is in this radio. Full. Oh. Yeah, let's give it a little more power here. Okay, so I don't know where we're tuned, but it could be tuned to a weak signal. No, we're not. So I just noticed there's registration marks across the top of this. These would be tuning points for the alignment process. But I don't have the alignment process written here on my sheet. I don't have it available. But I did see on here it says it's 460 IF. So first we're going to try to pick this up at 1 million. I don't need to hold it, but I am. Okay, that didn't work. I have no idea if this is going to... Let's put it right up here. There it is. Okay, now we're going to try the same thing at 460 and see if the IF frequency will come into the radio. Well, we're assuming the IF is tuned to 460. Okay, I'm going to turn up the level here. Nothing. Okay, so now maybe it's not at 460. So I'm going to put this there for lack of any other place to put it. We'll tune the signal generator. There it is up at 500. So that's probably because the last person tuned this radio without instruments. So we're going to try to bring it down to 460 where it should be. Let's see, it's got capacitor tuning, so we can probably get away with it. There. We're just going to do this by ear. Yeah, that's pretty good. Like that. There. 460. Okay, so this is tricky. Now I'm going to bring the signal generator where I want it to go, in the direction I want it to go, until the signal fades out and I can hardly hear it. I'll do that first. Wow, that's not very far. Now I'm going to try to bring it back. It's going to take a while to work my way all the way down to 460. So I'm trying to figure out which one of these is the most sensitive one and do that on the lead. I think this is the most sensitive one here. It's probably picking up radio stations while I'm doing this. Yeah, that shouldn't happen. Okay, not sure what's happening. We might have been picking up double this frequency through the radio there. Maybe this isn't going to work. We need a more positive. We need to know for sure that. We need to know for sure. Okay, so let's flip this radio up. Okay, you know, this is beautifully insulated, except it's not. It has a exposed metal mark point there, rather. Up here is good though. Hoping this coil would do it here. So if I mistakenly tuned that IF, it may be so messed up now it ain't coming back. Okay, so that could be what's happened. Okay, I'm gonna go more classic style. So much for rushing. So I want to tune this first. So I want to feed a signal through it, a known frequency out of the signal generator. So one way is to feed it into grid number 1 on the 12VA6. You could even go back further and start right here, which is right off the antenna. So let's just hook right up to the antenna, punch a signal in through that capacitor, and see what we get. Turn that down. My coil technique didn't work so well, but that's okay. Learn what doesn't work, you're still learning. In fact, what did I hear? I heard the other day a definition of an expert. An expert is a person who's made every mistake possible in a very narrow field. That's what an expert is. So we're going to feed this into the antenna here. I'm going to leave the ground open for the moment. Now, most radios this works. Oh, not enough signal. There we are. So it's still showing up way up there. Okay. Take it back. Wow, this tube must just be blazingly hot. I just feel the heat coming off it. Let's see if we can clean this up a little bit. Down we go. Give a little more power. There. Kind of overriding any other signals that are coming through here. There is another signal. That's the same thing I was doing before. Oh boy. Whew. Okay, so just making sure these are lined up at something. Listening to the noise. Pretty thoroughly messed up. She's a mess. Okay, so second L2, L1. So L1's probably the first one. L1. This way and get it right. L1, L2. So we're starting at L2 and we're going to try to get this signal through here. So I think I got this so whacked out now, it's crazy. I'm looking for a nice, strong, clear signal. I'm not going to find it. Okay, let's keep going here. Put this on full blast. Let's see if we can get it all the way down to 460 with a huge signal coming through. I don't think I can do that. Let's try to take it to 480. .460. Okay, I'm going to connect the ground at this point. And that should quiet the radio. Okay, 460 high level signal. I think I'm picking up the noise, not the signal. Wow. What's happening there? There's so much heat coming up off those two tubes, it's uncomfortable for my hand at this height. Oh, this tube is so hot. I don't think this is working out here. See, I think what I'm doing is I'm actually focusing in on some noise here. It's not what I want to do. Okay, so this isn't working. So I'm going to put the signal generator signal rate on to, I'll go back to what I was saying. I'm going to try to put it on the grid here, which is pin number, looks like 1. Pin number 1. Pin number 1 of the 12BA6. Okay, pin number 1 of the 12BA6. Oops. BA6 is the first of the 3 in a row. This one here. Pin number 3. Look in there at pin number 3. One, two, three. 3 is right up in here. The radio's off, by the way. Power's off. Okay, how's that look? Make sure we haven't shorted anything out. For sure that's pin 3. 1, 2, 3. No doubt about it. The signal generator. Turn down the signal level. Feed it in like that. Okay, stay like that. Radio. Okay, power on. Okay, radio's pretty quiet now, probably because I basically shorted it out. Shorted out the input to that. 2. Now, I've got a signal coming in, low signal, 460. Don't hear it. We'll pump it up a little higher. Not hearing it. So what I'll do is I'll tune the signal generator, find out if it's off frequency. Uh-oh. Uh-oh, nothing at all. We'll give it more. Come on. This is a little hard to believe. Well, give it even more. Oh my smokes. Okay, something's definitely not worked out here at all. There's no way this is... What is done wrong here? We're coming out. We're going in. Pick that tube. Tube's this tube, the 12BA6. 12BA6. Oh, pin number 1. I got it on 3. Hey, I took an Alzheimer's test this morning on the internet. I passed. I'm okay, believe it or not. Like my daily Alzheimer's test in here. I feel like I'm failing. Okay, I'm going to try pin number 1. Here it is. Pin number 1. Get on there. What is pin number 3? What were we on anyway? We were on a heater line. It's feeding the signal into the heater. That didn't seem to work well. Okay, down on the level. Power on. I'd say probably roughly 50 to 60% of my time is discovering the errors I've made while I'm working on stuff. Isn't that terrible? Okay, a little radio makes some sound. Okay, again, it may not make any sound because I've got this hooked up. So let's tune the. Let's tune it. Tune it. Volume's up. Power's low. Come on, baby. Oh, terrible. Look at it. It's all over the place. It's weakest at 460. Okay, I stand a chance now. I'm going to tune the... I got this thing turned around. I'm on to tune number 2, which is L2. L2 is at the back of the radio. L2 is this one. Really? No. Just trying to find every way I can get this wrong, of course. Oh, jeez. Scared the living bejesus out of me. Man alive. Okay. A little tiny radio. So much nonsense. Doesn't sound good to me at all. It's very distorted. Maybe way too high a signal. Volume's full. You know, we're not getting much volume out of this puppy. So I really am not liking this. Tuning shouldn't do anything. Well, how can I do this any different? back and forth. Maybe I haven't gone back and forth enough on these two. If they're that far out, I mean, they probably are because I did it. One capacitor is almost fully closed. I can't see how I'm going to get it any better than that. Okay, let's pop that off. If you want to do this one, want to feed the signal, and we can right on the antenna now, and we should be able to do this other IF without much trouble. That's the idea. Certainly don't want to change the signal generator now. Maybe make it more powerful. Okay, we'll start there. What happened there? Wait a minute, this doesn't make sense what I'm about. Yeah, it does. What am I talking about? Get on there good and solid. Okay, I think we're ready. Again, just doing this all by ear. Okay, enough of doing this by ear. Okay, here we go. Checking the meter. Yep. Okay, ready on the meter. Meter. Okay, gain on the meter. Oops, wrong hole. Okay, here we go. Nowhere to go there. This one here. Okay. So that's what the IF fed into the antenna still. I just turn down the level. Let's just, yeah. It's pretty good. Turn down the level so the AVC isn't quite as active. Touch more out of that one. We're talking about small stuff now. Okay, let's see how that is. Wow, those tubes are hot. Holy smokes. almost 200 degrees C. Wow. Don't touch that output tube or you're going to regret it. It's going to take the skin off your hand. Just bump it. You know, there could be a problem causing this too. Could be a problem with the bias on that too. We'll take a look at it in a second. So now we're ready to tune the radio. See what we get. Stations are down in this area here. Poor volume. Poor volume. Very hot output tube. Hey, that's starting to add up to something. If it wasn't for the low volume, that would qualify as not too bad a reception for a shop with this low radio. Very distorted too. Well, distortion could be output tube. So let's see what's going on with this output tube. First of all, the temperature is that a reasonable temperature? I can actually look it up. The output tube is a 50B5. I think this will even tell me the outside glass temperature on it. 50B. 50B5. Because of its high power sensitivity at plate and screen grid voltages available on AC DC receivers, it's capable of providing relatively high power output. So it works good with low B+, what it's saying. Outlines. Tube requires miniature. I'm not going to give the temperature here. Except for the basing arrangement, type 50B5 is identical with type 50C5. 50C5. Does it say how hot it's supposed to get? Bulb temperature at hottest point on bulb surface. 250 degrees C. Wow! Okay, so that suggests, even though it's a different tube, the temperature I'm measuring on the outside of that is not as high as it could be. 250 degrees. You can put a little roast right here and just cook it while you listen to the radio. So we do want to check the bias on that too. Let's see, how have they done it? I'm using a bias resistor, 150 ohm bias resistor right here. So I'm going to check the value of this 150 ohm resistor. I see it's not bypassed either. No, wait a minute. No, it's not bypassed. The capacitor around it to bypass it, then you get a little more oomph out of the radio. But let's see if we can find this 150. Oh, I'm sorry about that. Look, I should have looked at my screen there. So there it is there. Can you see it? 150. Power off. Flip her up. So that's going to be a fairly high wattage resistor, and it's probably pretty hot. This is probably the power supply high wattage resistor. That might be it up in there. It's not really high wattage. So that one is a something green. So that's not it, because we're looking for 150 would be brown, green, brown. Brown, green, brown. Hey, here's a brown, green, black. Yeah, it's right on the, no, it's on the rectifier tube. So we don't want a brown, green, black. Brown, green, brown, that would be 150. Yeah, that would be it. That would be a 150 right there. It's kind of mounted a little bit in the open, but it's on the rectifier tube. It's mounted near the rectifier tube, and that doesn't guarantee anything. And this other one, you know what? I think that's a brown. You know, brown, green, black would be 1.5 with no 0. That's a 15. This one appears a 150. There's a 15 in the power supply. 15 ohms right there. So that's the 15 ohm one. So the actual, it is this one up in here. Looks to be in good shape. But we do need to measure it. Now, measuring it in circuit. Okay, so you could get, I'm looking for any other circuitous route. Capacitor. I think you can read it. I think you can read this accurately in circuit. But what often happens with those resistors, if they go high, the bias gets higher and higher. The tube gets quieter and quieter, but it's okay. It doesn't hurt it. Okay. But if the resistor goes low, the bias gets less and less. You get more and more current through it. Tricky here to get this. Power is off. So it's reading 175 instead of 150. Nothing to get too excited over. The slightly higher resistance means a slightly higher bias, means a slightly lower quiescent current through the tube should run a touch cooler than it would otherwise. At the same time, you swing the bias too far and then the incoming signal on the grid will go below 0. I don't want that to happen. So another possibility is that the grid is being pushed positive from a leak in this capacitor here. Now my guess is that's what this yellow one is. It's already been replaced. That's my guess. So that would be on to pin number 1. So let's see if that yellow capacitor connects to pin number 1. It connects to number 2. Don't be fooled now. Sometimes there's spare pins and stuff like that happening. Well, there's 2. Oh, this is this one, 0.02. That's this capacitor. It's not this one. Okay, so we'll follow off of 1, and we should find a resistor and a capacitor off of pin 1. Let's take a closer look here. Ooh, radio, don't fall over. What am I doing? Who am I? Why am I here? What am I doing? I'm looking for a capacitor 0.005. Maybe it's this. So just trying to determine the focal point of this camera. That's way back here. Bear with me 1 second, maybe longer than 1 second. It'll be 4 seconds while I call up the properties dialog box for the camera you're looking through and focus it by hand here. Good for now. So we want to look back from pin number 1. This is pin number 1. And right away there's a capacitor. Hey, did he make a mistake on this? No. This capacitor has been connected in via the... He did the same technique I do, where you just leave the old lead wire in there, attach the new part to the old lead wire. So I never make mistakes when I do stuff like that. Why would he? This isn't the right, this is the other capacitor. What am I talking about? Back to here. There is no capacitor there. Okay, so this green wire appears to stop at this point. So I think that's connected there. So that, where does it go from there? Oh my God. It seems to come around and tie to another terminal here. That would be terminal 876. Terminal 6. What's going on terminal 6? Terminal 6 is the terminal 6 is grounded. B plus. B minus. Terminal 6. What are they showing here? Okay, so here's the whole schematic. Let's run through it really quick here. Well, just start with the power supply. So you see two heaters in series. You see the fancy thing I was talking about here, where they've taken a voltage off this heater. This is not center tapped. This is tapped to generate 6 volts. So you know there's like 35 volts dropping across this. So that's what this is. This is a tricky way to produce 6 volts. Of course, the thing is, then when you first turn on the radio, there's a rush through here. This 15 ohm resistor is because this isn't dropping enough voltage, I guess. That's why they put another 15 here. So this guy would tend to get a little warm too. Remember, he's up high and clear in the radio. Okay, so B plus produced out of here. Up it comes. B plus through here, reaching the plate and driving this tube. B plus on the other side of a 2.7K resistor. Oh, I see what I was reading wrong. I was looking at this wrong. So I was following this line up and having it connect here, and then connect to the suppressor and to the cathode. So I'm seeing the cathode connected directly to the positive. What? No. It's just, they just drew this just a touch longer here. I realized, yeah, that's the screen grid voltage, of course. So, okay, so that clarifies that. Now, the B plus line runs along here, it feeds all the plates through these coils, to this coil, feeding the plate and the screen. The screens are fed right off this line here. Well, there's only a so this is done a little different here. What's going on here? So we have the B plus showing something a little tricky here. That's not normal in a radio, not common anyway. I've never noticed this before. You see how that connection is not at the bottom here. It's one turn up, or so it shows pictorially, one turn up. So let's see, B plus comes in here, B plus goes through here, through this winding to arrive up here, and then it goes through this little winding to arrive here. I don't know. Okay. I mean, they usually want the screen voltage a little lower than the plate voltage. This almost looks like that wouldn't happen. You got me on exactly what they're doing. Some engineer got something clever going here. Pin, shield in tube socket. Pin, shield. Pin? Does that say pin? Pin? Pin, shield in tube socket. What's this here? That's curious. I don't know what's going on there. There's a couple of curious things in here. Hidden shield. Okay. And we just move back. Okay, so we've got the 460 going through here. Here's the mixer tube. It's receiving the local oscillator signal through this little funny little coil arrangement here onto the first grid. Picking up a little bit from this transformer. Cathode current is fed through here, so that induces a current here. We tune this guy. The big tuning capacitor, a little bit of the signals picked off here and sent up to the grid. So that's a local oscillator doing its thing. Then you come back to the actual antenna signal coming in here, basically right off the loop. Nothing too fancy going on in this radio at all. 0.05, so this is the AVC capacitor. 0.05. So the reason for low output would be a leak on this, still could be a leak on this capacitor. We gotta find this C13. We gotta find it. Okay, so I said plate on the 12AT, which is pin 7, and the 12AT is in the middle. It's right here, buried totally out of sight. Oh my gosh, how am I gonna see in there? We still haven't found this one. Oh, it's not in the, oh no. Okay, so this has a, there it is. No, it isn't. Yes, it is. Hello. What am I babbling about here? Look. Sorry about how the, you're not seeing the schematic very well, but behind this red resistor is a very early type of, I don't want to say integrated circuit, but miniaturized multiple component circuit into a package. I think actually the word package is used, I think. It's right there. It's right behind this red guy. The thing about those is they contain, like usually right around the tone control, if there is one, or in this area, a lot of these components inside that thing. Okay, so here it is right here. So this is a very simple one. It's just a bunch of capacitors. C10, 11, 12, 13. See, C13 is here. So C13 is in that thing right there. So what you can do in a case like this, if we guess that this capacitor is leaky in that little package, we simply stick another capacitor in here. How would we know if it's leaky? We take a measurement on here and see what the voltage is. It should be, like, we should read from the grid to the cathode the voltage drop here, giving us a certain bias. If we don't get that, and it's much more positive, we already know this resistor is, did I measure this? Yes, it's a little high. Expect this to be a little more negative, but this turns out to be quite positive, or very less negative, and there's a leak through here. That would raise the quiescent current going through this tube and heat it up, even though it's not as hot as maybe it could be. But we need to check these things. So I got to take a voltage reading on pin number 1. I think I can do it. Okay, voltage reading pin number 1. We're going to anticipate 2 or 3 volts. Make sure I get the right voltmeter leads here. Yep. In fact, let's avoid that problem. Get rid of this voltmeter. Okay, power on again. Wow, that light just goes like a flash bulb. What was that big bang upstairs? My cats are at it again. Okay, she's heating up. Double checking what I'm going to do. Pin number 1. Really, I should do pin 1. No, yeah, pin 1 to pin 2. I should not go to the chassis. That's a mistake. Pin 1 to pin 2. Okay, now I'm going to do this so we'll see a negative voltage on the cathode, on the grid if there is one. Okay, pin 2. Pin 1. Looks pretty healthy to me, -5. Woo. We're on full supply voltage. So that's a 50 B5. What is it looking for? According to the book, 50 B5. Oh. Yeah, look, 50 C5. Okay, so it's the same as this. So we're looking down here. Blade, grid number 2, grid number 2. Temperature, blade. Grid number 1, control grid voltage, should be -7.5. Hold on, do they have a typical operation here? So, blade voltage 135 max. So it should be up around -7, and it's at -5. You know, that's not bad. I don't think that would explain any problem in this radio, like distortion or anything like that. Oh, not there. Between. You know, it's -5.5 volts there. No concern. Low output could be a weak tube. You know, output tubes tend to get weak. So tube testing is next.